Hey folks, Quilly18 here, and welcome to another episode of Let's Build a Base Building Game in Unity over here, Project Porcupine. In the last couple episodes, we looked at moving the furniture definition code, the furniture prototype information out to an XML file, and that is currently working mostly fine. I mean, we are reading in the furniture, but what we are not reading in yet is the information required to set up a job. What is involved in building a wall? So right now, these jobs are finishing instantaneously, as well as requiring no materials. So what we'd like to do is tackle that step next. We still haven't loaded in the other pieces of furniture yet because we want to make sure that we've got the basics working before we go and do that, just in case it requires a bit of a change of structure. Now, currently, in the XML file, I did put together this sort of block here for like the building job definition. I guess there should be something like a work time variable in there too, right? If we look up at the job model, yeah, we have this job time, which we pass when we create the job itself, right? Job time. So I think it's probably fair if in our XML file here for the job, we include a parameter here, an attribute called job time, and we say it takes, I don't know, 1 second to do that. And same thing for the door. Something like that. And potentially it'll have a deconstruct job as well with a certain amount of time, but we don't really have deconstruct jobs implemented per se yet. So that's mostly just placeholder code. All right, so this sort of section has to be read at this point. And where do we do that? Well, probably in the furniture prototype read. So presumably we'd have just another section over here that was called building job, for example, where we would do some stuff. Now, the problem with this is right now, or previously to this, if we open up the world, oh, I guess it's doing a recompile. There we go. If we open up the world, it's in the create furniture prototype that we built the job descriptions right over here, for example, right? For the steel wall. Now, this requires adding something to the furniture job prototype database, which belongs to the world. And so should the furniture, as part of its read, do that? It's an interesting question and not one that's, clear, especially since right now, how we create furniture from reading it from the XML file. We are looping through the XML file. We find an instance of furniture. We create new furniture and tell it to read from the XML prototype information to create it there. Then we add the furniture to the database. I mean, it sort of feels like it should be something like here where we go furniture job prototypes and we set it to something. Problem is that might need another call to another XML file or something. That's actually an interesting idea. What if we had the furniture job information be separate? I mean, in a sense, it makes sense to have it here, right? Or we could have another XML file that's got all the job definitions. I think I like having it in here in the piece of furniture. And as such, we might sort of fudge a little bit of the order of things right over here. For example, I could do something like a public void register furniture job prototype. Or furniture prototype job. The hell did I call these things? I call it furniture job prototype, but that's not necessarily the way it should be written, but that's okay. Prototype, and it just needs a job J for a furniture F, like this, and all it does is it says our furniture job prototypes. Actually, instead of register, I'm going to say set, because register, like with our callbacks, implies you can have more than one, which is not the case. We're setting for the furniture with the object type of that. We are going to set the job for building it to be J. We're not really doing any error checking. Potentially, this could be adding to an object in this list that doesn't really exist in the other database. On the other hand, that's actually okay. Well, two things. One, that's literally what's going to happen, because over here in our furniture code, right over here, we're going to create a job J. We're going to do some things to set it, and then we're going to say world.current.set furniture job prototype, and we're going to say the job is J and the furniture is this. And really, we're going to be setting a furniture job prototype function for a job, or sorry, for a piece of furniture that's not actually in the world's furniture prototype database yet, but that's actually okay. So that's what we're going to do here. So we're going to be creating a new job, which requires a tile. Actually, that's going to be null because it's a prototype, and we can actually see that here, right, where we do our create furniture prototypes. We're doing this aspect. So just as a reference, I'm going to copy the old one. So we, actually, I guess I could do something like that. Right, so that's the sort of job we are trying to create right here and then register it for ourselves. But obviously, a few things. First of all, it's going to be our object type here. Furniture actions, job complete, furniture building, that's good. The work time, we're actually going to read. So we should read a few things here. We should float work time, or it's job time. I don't remember. Job time is equal to, and we're going to have to read that in from our XML file, where we do have it called job time. Great. So currently we're on the building job tag. So what we can do is say reader dot get attribute, and it's called this, and it's going to return a string, which we are going to parse, float dot parse. And right now it's worth noting that this will throw an exception if it fails. So we probably want to catch stuff like that. Right? And we're going to want to try to catch stuff like this with varying degrees of, what do we do about it? There is also the try parse version of the float, of these parses. But this is different. It returns a Boolean. It doesn't actually throw an exception. It returns a Boolean, true or false, if it's successful, and it writes the result to the other thing. So, I mean, what do we do if there's an error? For now, I'm actually not going to catch this. What I want to do is I don't want to handle this gracefully. At this point, if there's an error parsing this, I want Unity to freak out and give me, I'll see the exception in the Unity log. So, I mean, that's what I want right now. I want it to crash and burn. But at some point, we want to consider, what do we do if one of these things doesn't work out quite right? All these read contents and stuff like that. There's a big possibility for errors here if someone has given us malformed XML. And at some point, especially when we get modding and we're not just running things inside of an editor here, we are going to want to catch these things so that we can tell the user that there's been an error, not just output it to a debug log for the programmer. Big difference there. Anyway, so we'll grab that job time. That's going to be fine. So that's going to get stuck in there. But the next bit is we're creating this array of inventory to feed in here. So what are we going to do about that? Well, I guess what we're going to do is we're going to make a list of inventory. I'm going to call them inv equals new list, like this. And then what we're going to do is we're going to have to loop through. Oops, that's right. I have it open over here. We're going to have to loop through each of these inventory sort of sub things. So what I'm going to do is I'm going to create a new XML reader for ins reader, which is our current reader dot read subtree. So we were sitting here. This is where our cursor was. Now we're getting a new subtree that is currently sitting here. And remember, we could have multiple different requirements for this. So in this case, we're just going to have one inventory, but there might be more. So we've got one inventory requirement at this point. But again, there could be more. So what we're going to be doing now is we're going to be saying while ins reader dot read, then what we're going to do is we're going to be grabbing the information, which just requires us to check the attributes. Do we need to do this first read? Is it going to skip something? I don't remember if we have to do the read first or if we can just start reading. We might want to do a do while as opposed to a while. Well, let's do the while and find out, see if it works. Here, debug.log ins reader. Let's just do this. And we're going to run it as is. We shouldn't get any syntax error. This is obviously not going to do exactly what we want, but let's see if we can run it and check the debug information. Okay, inv-reader is definitely doing something, so presumably it's okay. But we'll see. Actually, what I want to do is just report what the node is, because that seems to be a little bit more noisy than it should be. Dot name. Some of these are probably blank entries. Yeah, and they are. And I think that's the closing inventory tag. Okay, so that's fine. So what we want to do is just have an if here. Dot name is equal to, and we are trying to read in something with the tag name inventory. So we only process that. We don't process the empty tags or the closing inventory tag or anything like that. We make sure it's that, and if that is true, then what we're going to do is we're going to create a new inventory, inv equals new inventory, and the type is going to come from insReader dot get attribute, and we're getting the object type field, which is just a string. Then it wants to know the max stack size. This is how much we're actually looking for. So that's going to be the one called amount. But we want this to be in integer form. So again, we'll go int.parse. Again, this could throw an exception, but for now we're just going to assume it's okay, because we really don't have a better way of handling it right now other than, yeah, let it throw an exception and we'll see it in the debug log. And then the current amount is going to be set to 0 because we're not starting with any. But let me just check. We've got that right? It goes max stack size, then current stack size. Yeah, so we currently have 0. So we do that, and then our ins.add is going to be this. We don't really need this actual temporary variable, but we're not really creating an extra set of data because it's really just this. We have a pointer going to it that'll eventually go away, but this can, I don't know. I guess we can just do this. And that is fine. Do that. Oops. Pull you back over here. And like that. Found an inventory requirement. So add it to the list. Boom, like that. And then here, instead of creating this array, we can just pass it the ins. Although I might just say to array. I think it would automatically convert it, but let's make it explicit because that's what it's looking for. It's actually just looking for an array, not a list. Okay. So if we find building job, we create this empty list of inventory, then we start a subreader, then we loop through it as many times as we can to find stuff, and then we create a new job with this full inventory array and register that. So now, if we hit play, I should no longer be actually able to build a wall. I should be able to queue up the jobs. Boom. But it doesn't work because we don't have the materials required. Same thing with the door, because in our definition file, we actually require the stuff to be there. So what I can do instead is, just for the sake of things looking pretty, I'm going to load the pathfinding test. I'm going to save, and I still have the little code that when I load, actually I don't, I'm lying. I don't have the code anymore that adds metal bits. Let's put that back in. So here it was. When we read the world, I'm going to just uncomment this. And now whenever we load a world in, it's going to spawn a bunch of metal plates for us. So load. There we go. We got metal plates. And now if I say build basic wall, there we go. We are back to working again. We have the walls. 1 second, it does feel like it takes a long time to build the walls, but I guess we're okay. Now, the one issue is, if I just reset this, those walls are still in there. Great. The doors still use material. I mean, they use material and they get built, and that's good. But the problem is that the doors still don't work. Right? They just go, we just pass through it instantly. And the reason is that for our door, what we had to make that work, create furniture prototype. For our doors, we have this isEnterable function. So all of our furniture has this potential, this action, this event called isEnterable. And what it is when a character is trying to enter a tile that's got a piece of furniture, it calls that furniture's isEnterable function. Sometimes it's null, in which case we assume the furniture is enterable, assuming that the pathfinding cost is not 0. So if the pathfinding cost is 0, this is a tile you can never walk into, and the pathfinding system ignores it. But the difference is a door has a pathfinding cost of 1, which means the pathfinding system considers it to be a perfectly legitimate and easy tile to walk through. But before the character, so when the character is trying to pathfind around our base, the pathfinding system is going to say, yeah, you can totally walk through the door. But when the character actually gets to the door and tries to enter that tile, it calls this is_enterable function. And this door is_enterable function has all the logic in there that says whether or not you can actually come in and enter it now. It could return, it's got 3 states it can return. It can return sort of true, yes, you can enter. It can return false, no, you can't enter. There's something that's gone terribly wrong. You actually can't enter this tile at all. In which case, the character will reset their pathfinding system, because most likely it's just something in the world state has changed. And finally, there's a third state, which is, yeah, it's technically possible to enter this tile, just not right now. And that's what our door does. And our door also, whenever our door gets, this is_enterable gets called, our door assumes someone wants to come into it, so it starts opening, and then just tells them to wait. And then once the door is fully opened, then it actually returns true to the question of, can I enter this? And then once people are done asking if they can enter, then the doors just start closing again. So we have to get this kind of attachment back. And how are we going to do that? Well, there's not really an XML. Actually, what I'm going to do is I'm going to go and re-implement the other furniture first. Because what we're going to have to do to get the doors working again and having their logic is we need to link some code in there. And I mean, while I could do something like, some sort of, is enterable, and then have a string here that we just feed in, which is just like, say, the function name, for example. Where was it? Say this whole thing here, like that. But, that's not code we're going to parse like this. This would probably be a string that we then look up in a table or some damn thing like that. What we really want at this point is maybe some sort of Lua code. Same thing, and more importantly, and yeah, I guess I could leave this in because we're actually just not going to process this tag. If I go and create a new tag at this point for, say, stockpile, which also has a bunch of logic to work, right? But I could get it started. I should do the thing again where, no, this is okay. Let me just copy this into furniture. At least I can't use it as is. But copy this part, go there, and the closing furniture tag, and woo, it's getting confused. Like that, and like that. And so this is stockpile, which has the name stockpile, which is completely walkable, and doesn't have any of these. And again, with this, I could just get rid of these. In fact, I could get rid of the width and height as well, because they all default to things that are reasonable. Same thing with the movement cost, actually. I can get rid of all that stuff because we actually have defaults. We're quite happy for that. What else furniture do we have? Oh, no, it would be in world over here. So the next thing is the oxygen generator. And again, these could have codes, right? Like, this doesn't have to be door. This should probably be something like this. Stockpile's a bit different. Fern, O2, gen. Oh, that will break all my graphic links, actually. So, you know what? Let's just leave it for now. Oxygen generator is the name. Now, you actually are slightly different. Let me close these so I don't keep going to the wrong place. In that you're a 2x2 and you have a pathfinding cost. So we make it difficult for you to walk through so that mostly our characters avoid it because it looks better that way. Our mining drone station. Actually, let me go and do this. Also, our mining drone station should have the pathfinding cost as well. But more importantly, it's a 3x3. But yeah, I'll put in the pathfinding cost of 10 so that our character doesn't like to walk through it. Well, I say that. It's right. The mining drone station has the problem because the seat is currently part of the mining drone station. And therefore, to work it, you have to do this. You'd have to do this really slow walk into the tile where you're supposed to work it. Not to mention also if you want to go and pick up some stuff because that would all be part of the base. Later on, the mining drone station is actually going to be a 3x2. And then we can increase the movement cost. But that is still a little bit unfinished. So if we do that and run this, we should have all of our buttons back. Actually, is that really it? Mining drone, oxygen, stockpile, door, wall. Yeah, that's it. And they're all back in there. If we load this, we'll try to bring the mining drone. There we go. We've got it. But again, it doesn't do anything. It has no attached code whatsoever. So we have to figure out where this code is going to go. Part of me worries about making like the code in the XML file too big. You can input other code in XML because you can sort of escape areas to like what's it called? Is it C data or whatever, where it starts to ignore? Because last thing you want to do is, let's say we had a code section. Oh, well, there you go. I think what you do with the character data, I might be remembering this wrong, which is why I didn't want to do it right here. But we do something like, this is some sort of code block, right? This is the on update or whatever. Because the oxygen generator would have something like this. So our wall wouldn't. Oxygen generator. Right? Because oxygen generator automatically runs something on update every time. I gotta remember the format for this. What does that look like? How do we open and close it properly? Dun, 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 dun. Oh yeah, is it still character data and comments? I don't remember. I think this is legit code. I think you can put code in here, but I might be wrong. I'll double check. I'm sorry that I'm right. It's still part of the document while a comment is not. So this would work, and we could embed Lua code here, and that's kind of cool. The downside of doing it this way is that we won't get any character formatting in this file because this file will assume that it's XML, right? So MonoDevelop won't know what to do about this. It won't, quickly flag, if you've got an unmatched set. Well, it still auto completes that, but it won't tell us if we've got, a broken whatever because it doesn't realize that it's actual code. But as long as our Lua code is relatively short, this becomes a really good and kind of sexy place to embed this. Alternatively, we put our Lua code in a separate file. But the problem then is still, how do we call it? How do we tell the oxygen generator that on update it's supposed to run a function from the Lua file? Well, it's going to partially depend on how we implement Lua, the Lua interpreter within Unity. But we can, I believe, with the Lua interpreter I'm looking to use, we can call a function. Like, so we'd have a Lua file, we'd parse it, we call this library to parse the Lua file, so then we'd have this sort of object, this instance of an object that we could call, my Lua code dot execute function, and in parentheses, you put in a string that represents the function name, which means at that point, over here, we can have something like maybe a self-closing tag here that is something like Lua function name is equal to on update 02 gen or something like that. As long as we had a function in our Lua code that was called this, then it would run. And I think I'm kind of leaning towards this because I think it would keep our XML file a little bit more minimal and a little bit more manageable. It segregates the XML from the Lua, which means you get like syntax, coloring, and all that. It also makes it a lot easier to reuse the same function because imagine you had two separate objects that both used effectively the same code. Maybe they had a custom parameter, right? Like let's say we have two oxygen generators, right? And this is the turbo version. And we had some sort of parameter, right? So we have params. Let's say on both of these, you had a param called, gas speed or gas per second. And for the turbo one, we did, 10 units of gas per second, whatever, that's supposed to represent. And over here, we had a separate parameter. And this one here was just, it wasn't quite as good. It only does, 2.5 units of oxygen per second. And then this Lua function interacts with these parameters. And in fact, that's very much what I want to do. I want the Lua code to have access to everything in params. Not the rest of it, necessarily. I mean, maybe, I don't know. We'll figure it out. But definitely all the params is all stuff the Lua code is meant to interact with. Because the whole idea, if you take a look at our furniture actions code as is, this thing represents the thing that is supposed to be the Lua. It's working with these parameters. That's exactly what it's supposed to do. Or it's supposed to have some ability, like in the case of the oxygen generator, right over here, to interact with the furniture, the tile, the room. Like, it can call some functions. Clearly, we'll have to expose some amount of stuff to the Lua side so that it can call these public functions. And that's the point at which we will really start to concern ourselves with what is public versus what is protected, because Lua code is all going to be moddable, and what do we want people to have access to in the mods? In particular, we want to make sure that they can't make a mod that is like super dangerous. I'm not entirely sure what that would be, but we'd still have to be a bit on our toes for that sort of thing. Yeah, so anyway, that's what we're going to look at, and I think I kind of like this idea. I'm going to get rid of the turbo version of the generator. But right now, actually, we have, in our furniture action, we have hard-coded in like the gas limit as well as the gas amount. So I guess really our oxygen generator is currently doing, is it that much? No, even less than that. That much per second right now. And gas limit. I guess this actually be a gas generator like this. Gas limit is 20%, and gas name is O2. Now all of a sudden we're set up with something, and we talked about doing that before. The oxygen generator is, can we make a generic form that just generates all gases? And that's really what we'd be building here. This thing here, this gas generator, would be reading all these parameters to know what gas to generate, how much to generate per second, and at what point does it stop generating gas, because that's the atmospheric value that we're looking for. Okay, not gonna lie, next episodes, plural, are gonna be a little dicier because I've never embedded any kind of code interpreter inside of another program before. I think it's going to be fine and very manageable, but we are going to be learning that together, and I'm really excited because it's quite cool. Also, why Lua specifically? It just seems to be very popular. Really, any language could really be embedded in any other language. Obviously, a language that is meant to be an interpreted language as opposed to a compiled language works a lot better. But there's really no reason why we wouldn't be able to use a JavaScript interpreter, or I guess a PHP interpreter, or a Perl interpreter, or a Python interpreter, all these different things. But for some reason in the gaming world, Lua really got established quite early on as the preferred embedded language for programming. I don't know why. There's probably some cool historical reasons for it. Maybe it's just, really good for this sort of thing. Maybe it's really quite minimalistic as a language, therefore it runs really efficiently. But I know that World of Warcraft, which had modding like right from the very start, has always used Lua for that, and quite a few other things have as well. And there's at least a few good options for Lua interpreters, so we're going to be looking at that. And there is at least one that's like nice and free and open source. So things may change between this episode and the next one, depending on how my research goes exactly. But almost certainly that's what we're going to be doing next time, is doing the embedded Lua code, and that's going to be great because, again, not only is it good for just modding and stuff like that, but I actually think we will be able to develop more furniture types a lot easier by having this runtime code available. In fact, we could even get our program to the point where we don't have to recompile the program or restart a program when we make changes to the XML file or the furniture code. There could just be a reload button inside the game that reloads all of our prototypes and reloads all of their attached code at the same time. And that would not be very hard to do at all. And then all of a sudden you've got game development that goes a lot faster. But of course, one of the big appeals is modability, or even when, and this is going to happen probably relatively soon, like my particular plan for like phase 1 of development is very much nearing the end. At which point, the focus will be getting this properly established on something like a GitHub and starting to really fold in a lot of community contributions. And I'll be moving a little bit away from maybe some of the tutorial-y kind of style for this game development, although I'll still be, looking at particular things, features I want to implement, and I'll make videos out of that. And instead, it'll be a lot more managing of the community-driven development of this once we've got the baseline stuff in place. And again, this Lua stuff is going to be important. We're not quite going to be at the moddable level yet because it's still going to involve stuff that is actually within the Unity asset stuff, but hopefully soon that will change as well. Anyway, thank you very much for watching, folks, and I'll see you next time. thank you everyone who pledged on Patreon to support these videos back in May, and are therefore keeping this series going from June through to early July. And a special thank to these Mike Check level supporters. We got Speedy Savant, Valiant Cake Fiend, Aaron Toibson, Marius Field Vold, Jan Torrevel, Julien Auger Lafont, Steven Stager, Michael McClintock, Kale the Quick, Drazion, Adjective, Jason Yanity, Wes Oldenboving, Craig Mortel, Neil Bulkley, Milner, and absolutely everyone who watched, shared, favorited, and subscribed these videos. Thank you very much for keeping this series going, and I'll see you next time.